Time for a blast from the past. I found this old mobile radio in my loft in a plastic bag where it's been dumped for many years. This is a 2-metre transceiver mobile rig. As you can see by these mounting brackets, it used to slide onto a plate. It was a quick release sort of system. It's a homemade radio, and how big is it? Well, let's do it in millimetres. 170mm wide, 190 front to back, something like that, and 10, 20, 30, 40, 50, 60mm high. How does it compare to a mobile phone? That's a modern small mobile phone, and that's about thing. So it's quite a chunk. It's quite a chunky rig. I think it was based on the ICOM 225, which was a synthesizer rig, and it was built in 1979. So what's that, 40 something years ago? Not an IC225 or a copy of an IC225, it was inspired by the 225. It's this bit here, the selecting the megahertz and then the kilohertz with 2 switches. I'll show more about that in a minute. This is the front panel with the megahertz selector and the 2 LEDs lit up to show which megahertz it was. So to select 145.5, for instance, it was 145.500, and to select S21, which was 145.525. There you go, 525, 550, 575. That switch has only got 4 positions. 600, 700, 775, 144, 775, 146, 775. You get the idea. That switch was for listening on the repeater input frequency, and that one marked listen through was for activating the receiver at the same time as the transmitter, so you could listen to your signal through the repeater. It's a full-duplex rig, it could transmit and receive at the same time. There's an S meter with a reasonable calibration on it. It was a proper logarithmic S meter, which made it very useful for direction finding. And if the signal was lower frequency, it would light that LED there. If the signal was higher frequency, it would light that one there. And if it was bang on, it would be right in the middle, and neither LED would light. Down here you've got the on-off switch, and it was simplex if it was down, or duplex if it was up, for repeaters with a minus 600k shift. And you got the squelch and volume controls, the ubiquitous 4-pin microphone connector. On the back we had a bulging connector for power input and speaker output, and an antenna socket. And this here was the receiver input. That was the output of the transmit receive switch, which is pin diodes. So you could take this off and stick a duplexer on and have this running full duplex. And that was just an accessory socket which was audio in, out, push to talk and all the rest of it. That was used mainly for packet radio. It's a two-part case held together with these strips on the side, and you can lift it off like that. So let's lift off the covers and show the horrors inside. This is the inside of the rig, which has had many modifications over the years. Bits and pieces tacked on for various functions, mainly packet radio and driving transverters and all sorts of things. I know there used to be a combination of these switches which would allow it to drive a QM70 Cobra transverter for 70 sems. There's even a date here, look, 8th of April 1979, I think that is. This was an inverter to produce 15 volts from the input voltage from the car battery, which could vary quite a bit when you're starting the car. So this was an inverter which provided a stable 15 volt supply. What else? That looks like the local oscillator. That was the front end with that's a MOSFET run at a very high current, so it's got a heatsink on it, and somewhere in there was a double balance mixer, but I can't spot it anywhere. Oh, perhaps that's it. Perhaps it's there. I don't know. Here was a 25k spaced rigs, hence the 15k filter. Second local oscillator. The IF amp is buried under there, under all these modifications, and that's probably an LM380 audio amp there. So this must have been the receiver strip. I'll have a look at the other side now. The other side, the case comes up just as easily. See, it's built on a focus, will you? It's built on a three-piece chassis. There's a central piece, a front and back and front panels, hence the screws there and there. And there's the gubbins on the bottom. Crazy. Right, that's obviously the output amplifier. Do you know, I haven't got my glasses on. Yeah, 2N3866 driving some sort of power transistor. I think, yes, the pin diode aerial switch was in there. That's the aerial. That's the pin diode aerial switch with its output to the receiver. Yeah, there's the receiver input going to, I think it must go up underneath somewhere. Yeah, the screening round the input socket and the DC input, feed through capacitors everywhere. I think this is because it was a full duplex rig. It was intended to keep all the nasty feedback out. This is the synthesizer board, which actually says synthesizer on it, which was 4, 5, 6. This is CMOS logic, isn't it? what's that chip? 40 CD4059. And there was a pre-scaler somewhere. One of the chips was a pre-scaler. Maybe it was that one. Plessy one. Bit of a diode matrix for something or other, I don't know what. Look at the panel illumination. A good old bulb shining through a gap in the bottom of the meter. So this was the microphone input. This was the transmit mixer. Now this thing used 133 megs from the synthesizer, and it had a 10.1 and 10.7 meg crystals, I think it was. So for simplex you added 10.7, for repeaters you added 10.1, and you modulated that with FM and mixed it in with the 133 megs, and it would drove the transmit output somehow. So yes, it was direct FM, the 10.7 megs added to an IF frequency, to a local oscillator. So, but I think it was a similar sort of arrangement used in the ICOM 225, except they used crystals in their synthesizer, and this used a bit of CMOS. I don't know what else there is to say about it really. There's no speaker, there wasn't room for a speaker. So the audio came out of the bulging socket at the back there. Again, this has been heavily modified for alternative purposes. Originally this was very tidy. I wonder if it still works, that's the thing. Shall we power it up and see? I've now hooked it up to a power supply and a speaker. I didn't have the right connector, so I've had to use a few croc clips to do this. And let's turn it on. This is the first switch on in a couple of decades perhaps. Will it blow up? Ooh, there was a noise. Right. Oh, it's a light. The lights are lighting. Yeah, something's going on. Actually, I don't know what these LEDs are. It's gone bright in here, would you believe? The sun's come out. I think that one lights up. That's the squelch LED, isn't it? I don't know what that one is. Is that repeater? No, I can't tell what that one is. And squelch opens. Plenty of volume. That still works. So I wonder if it actually receives. Now there's the test. I've taken the scanner and set it to 145.7. So I'm going to set the radio to the same frequency, which is 145.700. You could use this in the dark, this rig, because you could feel those. You could count the clicks. So this is perfectly possible to use this rig in the dark. Right. The moment of truth. Does it work? Hello test, hello test. Is it working? I'll just go out the room. Here's the speaker. Hello test, hello test. Is this working? Hello test, hello test. Hello test, 1, 2, 3, 4, 5. There's no aerial on this rig at the moment. So yes, it works. Well, it receives anyway. I don't know whether it transmits. I've got no dummy load on it, and I've got no suitable microphone for it. So we'll have to take that one for granted. But I'm surprised that after all this time it hasn't blown up. That's something. Something intermittent there. But there's no great heat coming from it or anything. There's no fizzing, popping, crackling noises, so the capacitors haven't exploded yet. Just for the sake of completeness, I put a dummy load on the back of the thing, and I'm now going to use a screwdriver to short out the push-to-talk pins. I don't know which ones they are, but let's have a go, see if we can find them. I don't think we can do any damage. Oh, there we go. Transmit light comes on. And there's the signal on the radio. It's a pity I can't demonstrate the transmitted audio, but I would have to find the microphone, and I haven't got a clue where that is. It was an old Pi microphone, similar colour to the case, which was typical Pi colours. It was done to mimic Pi colours, I suppose. I don't know. Anyway, I used to use this rig a lot. You know, from 1979 to probably 1984 on 2 meters. And in those days, you couldn't go on a 2 meter repeater without getting jammed. Hence the listen through facility. Because you couldn't, if you had a QSO and you were being jammed, well, there's no point, was it? There's no point in continuing. So you listened through. And if you heard yourself being jammed, you just stopped talking. And so I usually had a duplexer on the back of here. And that worked very well. There were some big jamming signals in those days. It was a bit of a free-for-all. Then we had a 70SEM repeater, and I used this to drive a QM70 Cobra transverter to generate a few milliwatts on 70SEMs. And that had to be duplex because it was a 1.6 meg shift. So hence some of this logic in here, that all of this extra gubbins that was added was to drive the synthesizer to a 1.6 meg split instead of a 600 kilohertz shift for the 70SEM repeater. So yeah, I'm starting to remember what some of this was for now. And I suppose when the packet revolution came in 1987 thereabouts, this rig became repurposed as a packet radio rig, and I think it spent the next 20 years or so on 145.600 or 675, I can't remember. So it was on 24/7. I'm absolutely amazed it still works. God, and there was another thing I was heavily into in the early 80s, which is direction finding, especially when we had so many damn squeakies about and things like that. So we used to do a lot of DF hunts, and this rig was good for that because the IF amplifier chip, and I can't remember what it was, I've been trying to figure it out, but it had a massive range on the RSSI output. It had a logarithmic output. So each of these S points was true 6 dB per S point, and it goes from 1 to plus 30, so there was a massive range. It was a brilliant rig for direction finding, because it didn't just saturate the moment you got near a signal. You had to be within a few hundred yards for it to get anywhere near up here, and to get to the top you had to be virtually on top of the station. And I think that in those days, this is before the transverter, if you put both of those switches down together, it caused an attenuation on the receiver. So there's all sorts of logic. That's what all this extra gubbins is about, I think. Hope you found this interesting anyway. Bye.